hold tight again. We haven't forgot about you. We're all still here. Just need for the beast. There we go.
I'm going to turn off my camera, see if that helps. I truly apologize for this. Let me share my. I also disconnected all my external monitors, so hopefully that helps. Let's see. I share my entire screen. Excellent. So can you guys see that? Yes, okay. So again, I was talking about scaling. I try not to jump to the portal now since we don't have that much time, but it's super easy to go and just change the throughput that you allocate for an application. Now, the great thing about this change is that you don't have to put your application or your database on pause, right? There is no session interruption. The scaling happens online. That's very different from what you're used to in traditional relational databases. Now, in Cosmos DB, there is something called request units, and that's basically how you pay for, right? Request units is a proxy for the amount of memory, CPU, and IOPS that we put behind the Cosmos DB server, right? So when you pay for Cosmos DB, you pay for a number of request units per second that you've set up for that database, okay? And usually, right, one request unit means, or it's equivalent to reading one document of 1 kilobyte, right? Now, there are 3 different modes or models for throughput, right? The way you pay for the database. One is what we call provision, right? So you specify, in this case, 5,000 RUs per second. I'm gonna, my application, I know the pattern is very, as you can see, is very steady, right? That line chart represents the pattern of reads and writes. And you know that the combination of that over time never goes over 5,000 RU per second. Now you can programmatically or manually increase or decrease that number, remember, right? But in the case of provision, is fixed there. Now, as I mentioned, if the pattern changes, right, let's say it's close to 5,000 RUs per second during the day, but at night the traffic gets reduced to half, you could have an Azure function that's constantly monitoring the consumption and just automatically lower that value of RUs per second. And you do this in order to pay less, right? Because you basically pay for the number of RUs per second that you allocate to the database. Now that's one model, right? The provision model. We also have what we call Autoscale, right? What happens if your workload is not predictable, right? It's all jumpy, as you can see here in the black line chart. Well, in that case, the system is gonna just increase and decrease the number of RUs per second, follow closely your needs, right? That's what we call Autoscale, and that's all managed automatically, so you don't have to do anything. Okay, this is great for environments where the workload is not predictable and it can spike or it can go down all the way to 0. Okay. Now, without the scale, you still get all the guarantees for throughput, low latency, and availability. Okay, so you have those two models, the provision and the Autoscale. But what happens when you don't need the guarantees, right? Maybe you are on development, or you are on test, or you are just testing something new, right? A prototype, a proof of concept. Then you can use serverless. And in serverless, which is on the private preview right now, it's not generally available yet, you basically pay for the number of RUs that you use, right? You don't provision anything in advance that you can later manually or automatically change as your workload changes. You just pay for exactly what you use, okay? Summary of the 3 models, the standard model, right? When you have a predictable workload with changes, but changes that are predictable, an Autoscale that you'll use when you have this spiky workload that you don't know how it changes. There is no discernible pattern there, or serverless, where you just want to pay per transaction, basically. Okay, good for development environments that don't offer SLAs on consistency or throughput. Okay. So as I mentioned, there are multiple data models that you can use, multiple APIs, right? One example was the Graph API. And if you store your data as a graph, you will use Gremlin to query that data. If you store data as a column family, you may prefer to use Cassandra for that, right? For documents, you may want to use MongoDB or what we call the core SQL API. It's not SQL in the sense that it's relational or structured in that way, but it offers a SQL-like language to query and traverse your documents, right? Including functions to traverse hierarchies of documents, embedded documents, and arrays. Just like on traditional relational databases, we have indexes. Unlike traditional relational databases, these are automatically created on every data element, right? So you don't have to manage it. You do have the option to exclude specific paths on a document, so they are not indexed. But other than that, they are managed for you, and you can just use them, right? So very, very, very good for developers who don't want to worry about the management or maintenance of these artifacts, but they still want to benefit from the super fast queries. For now, let's keep the Azure portal demos. At the end, I want to see if I can jump back. Messing with the browser is what's been kicking me out of the session. So I'll just try to keep on the slides here. And just triple checking, can you guys still hear me? Yes, thank you. Okay, turnkey global distribution, right? What happened when you have an application that maybe starts here in the central of US, right? And then you start having customers maybe in Brazil, maybe customers in Eastern Europe, maybe customers in Australia, right? What you want is to reduce the latency for those customers and replicate your database in an easy way so you can deploy your application closer to where the customers are, and those applications can read the data from the database that's closest to them, right? And for that, we use global distribution. Now, this is just an example. You can see a screenshot here where you have an application that's running on the West Coast, right? And a database that's sitting all on the other side of the world, right? And as you can see on the screenshot, the latency of reading data here is 210 or around 200 milliseconds or 178 milliseconds, I guess, right? And that you may say it's okay for some applications. For some applications, it's not great, right? Remember, we're talking about applications that require very low latency. What do we do to address that problem? Well, we go to Cosmos DB and we create a copy of that database that's sitting on the West Coast, right? And by doing that, the application will leverage that copy instead of going to the other side of the world. And by doing that, we reduce the latency of your app to single-digit milliseconds, which is great, right? This is what you expect. Now, this is no changes on any of the architecture of the application, right? It's just by making a few changes in the Cosmos DB side. How do the changes look like? You go to the portal and you just add additional regions. Now, when you have more than one region, there is a possibility that one of those regions will become unavailable, right? And for that, you have failovers. And there are many types of failovers, right? Automatic or manual. For automatic failover, you just enable that in the portal, as you can see on the screenshot. And based on the priorities, the next region available will become the right region, the right or primary region, okay? As you can see, failover has happened here, and Central US move up to the right region. How does that look like in your code? Oh, by the way, that was the default, right, for the entire system, but you on your application can override that on your code. As you can see here, I'm using the preferred locations. It's a policy when I connect to Cosmos DB, and I specify which one is going to be my primary data center, right, my primary location or region, second and third preference. Right? And I can do that, and I can inject that dynamically as I deploy my application on different data centers, right? That's part of my CI/CD pipeline. So pretty good way to make sure that the application talks to the database that's closest. And by the way, if you have architects there that want to test the failover, you can actually go to the portal and manually failover one of the regions. Check how things work, right? You will see some of the applications will still work, but may have increased latency because now they will be talking to a database that's far from where they are deployed. But it's part of your tests. Now, some applications require you to react to changes on the data, right? So think about IoT, gaming, retail scenarios, right? Where there is a large amounts of data, and maybe you want to detect anomalies or some data that may be above or beyond specific thresholds as the data gets inserted or captured, right? And for that, Cosmos DB has something called change feed. And change feed is like a trigger, okay? Well, it behaves like both a trigger and a queue, right? Where everything, all the transactions that happen on the Cosmos DB database get also copied into this queue, right? And other applications can read the queue and based on business rules, do something with that data, okay? So that's how it works, right? As new event gets inserted into the Azure Cosmos DB database, they get copied to the Cosmos DB feed. Some scenarios where this could be used, stream processing, right? And you can read from the feed using stream analytics or data breaks, streaming processing. You can use that to do event computing notifications, right? Or to move the data, right? Maybe you want to move the data that's being inserted into Cosmos DB to a different repository, right? Or maybe as you insert it in the Cosmos DB, you want to aggregate the data and then store it in a different repository. So many scenarios available there. Another one is event sources for microservices, right? We are used to use Kafka, for example, right? The change feed on Cosmos DB behaves like a queue, just like Kafka, where other applications can read the data directly from the queue as opposed to reading it from the Cosmos DB database directly. I'm just gonna skip through some of these slides. I'm sure I have time to cover all the material. Now, one of the features that was recently introduced in Cosmos DB is what we call Synapse Link. And if you haven't heard of Azure Synapse, strongly advise you to Google or Bing that. Find it online. It's a very cool piece of technology, right? The problem that's solving is a problem that we've had for many years, right? When you have a database or a data store that's designed to be a transactional data store, right? It has all the guarantees, the single-digit millisecond response time or latencies, right? And at the same time, we want to query that data, right? We want to query that data in real time, maybe some complex analytics, right? Way beyond the scope of traditional OLTP processing. And the way we've solved this in the past is, well, we create data warehouse or we create data lakes. We ETL, right? Extract, transform, and load the data somewhere else where we can attach a different compute and perform our queries there. Because that's a pattern that's very common, Microsoft decided to solve it for you, right? We've eliminated that barrier by creating what we call Synapse Link, right? And what Synapse Link does is it creates a secondary copy of your Cosmos DB data, right? Your Cosmos DB has a transactional store, and it creates an analytical store, right? That's column-oriented and compressed and highly optimized for analytics, right? This is automatically created for you. You don't have to, well, you actually have to check a checkbox for that to be available, and all the data gets automatically replicated, okay? And there are some complexities that we don't have time to go over, but think about what you're storing on your traditional NoSQL database. It's a document, right? And a document that has a schema that evolves over time. And what you store in something called birth date, for example, could be a date, could be a string, could be a number, right? So those representations are mapped to this analytical store in a way that make it easier for you to query that data later, right? And because of Synapse Link, you can log into Synapse and use Spark, Apache Spark, or T-SQL to query that data natively from this new storage without really having to store a copy of the data manually, right, without having to maintain these very expensive ETL processes. And this is a great differentiator, and it makes reporting out of an operational database like Cosmos DB a relatively easy proposition. Now, these are some of the scenarios where you can use Cosmos DB, right? One example is real-time telemetry, right? So you see some examples, Johnson Controls, Toyota, that when they want to capture data in real time, we're talking about high amounts of data, right? Thousands or millions of events per second. They can rely on Cosmos DB to store that data, okay? In this example, they are using a feature called TTL, right? Where the data expires after 90 days, gets automatically deleted. But you also have a Azure function that's probably reading the change feed that creates a copy of the data on a different repository. I'm pretty sure this slide was created before Synapse Link existed, because now you don't have to do that, right? That secondary copy for reporting purposes is already available. Real-time personalized recommendations, websites with recommendation engines usually leverage Azure Cosmos DB as a fast cache, right? Remember, because we have this very, very low latency on reads and writes, you can use that database as a cache, right? It could be a key value or a more complex data store for data that you want to use on a website. Finally, I mentioned geo-distributed or mission-critical applications, right? If your application needs to have, need to run 24/7, and you probably want to have a copy of that in different places, right? As accidents may happen, an entire region may go down. You have a live copy of that data somewhere else where your application just can point to that and continue working. So it's great for mission-critical apps. I'm migrating from Nosql, right? Some of you may have used already MongoDB or Cassandra and HBase. Setting up, maintaining, patching, upgrading, taking backups, it's not an easy proposition, right? Even configuring those databases is relatively hard, requires specific expertise. We manage all that complexity for you, right? On a single database that exposes all these protocols. So if you are tired of having a troop of DBAs or developers managing a Cassandra cluster, we can certainly do that for you so you can focus on activities that provide real business value. These are some of the top use cases for Azure Cosmos DB. You can see, right? The rows are the use cases and some details around them, like real-time telemetry, IoT, real-time recommendation engines, and mission critical, the same ones that I cover with a little bit more detail on some tips on how to optimize Cosmos DB to work better on those environments. Finally, I'm pretty sure some of you are super excited about using this technology and you want to try it on your application, but you don't want to pay for it, and that's perfectly fine because there are many ways to use it for free, right? The first one is if you want to use it on a production environment and you already have an existing account, you can use the Cosmos DB free tier. You can go right now to the Azure portal and create a free Cosmos DB resource, right? Or you could use a free account, an Azure free account, which is, if I'm a student, for example, I will use that. You can also have the emulator, right? You can download that, run it. I believe it runs on containers now, but if not, you can run it on your Windows computer, and it emulates the Cosmos DB, so you can connect there, code there, develop there. If you're in the airplane, for example, just work with the emulator. When you land, you can connect to your actual database. Okay. Now, I went over some of the most important features of Cosmos DB really fast, right? If you want to learn more, go to Microsoft and learn. There is plenty of content, not only around Cosmos DB, but many of the Microsoft services. There are entire learning paths with multiple modules, activities. And if you go to the Cosmos DB modules, you may run across some of the ones I actually updated recently. Finally, since we have a couple of minutes, I'm going to try to jump to the portal and see if I can show you some of these things, and if my life doesn't die on me, okay? Okay, so let's see. This is the Cosmos DB database. If I go to replicate data globally, it's working now. I have right now a copy of my database in the East region. If I wanted one here, or let's say one in South Africa, I can just click South Africa. Actually, that one has some capacity problems. Let me check other like West Europe. You can see how they are added. Maybe a Japan West, maybe one here in Australia Southeast, and I want one in Brazil too. So now you have all these copies of your data, right? Some of the data center support availability zones, you can do that because every one of the Cosmos DB databases already maintains 4 copies of the data. Okay, it's already highly available. But with this, we're adding multiple copies in different parts of the world. And the only thing I need to do is just click save here for that to work. One thing I'll show you quickly, I mentioned the stream, right? Change feed. It's very easy to connect or to create an Azure function directly from this service, right? And the only thing I need to select is basically what language I want to use, C# of JavaScript, and this will create an Azure function that gets automatically triggered as the change feed gets up to date or updated. And finally, I mentioned Synapse, Synapse link integration. This is the Synapse portal. If you haven't seen that, it's great. By enabling Synapse link, I get a chance to see my Cosmos DB data here, and I see my 2 containers. This is my database, these are the 2 containers, and this is the IoT data, okay? And it's relatively easy for me to write a notebook, and I won't run it right now because we're about to expire in terms of time. A notebook that uses, in this case, Apache Spark. I could use T-SQL too, to query the data, right? And this is the same data that's on the Cosmos DB database that's replicated to the analytical store using Synapse link. Okay, so as I query the data, I maybe create some complex, crazy queries. I'm not affecting in any way the RUs that I provision for my Cosmos DB database. That means I'm not affecting the performance of my applications. Right? I can run counts. I can create a table, right, that's pointing to that operational data, analytical data store, and I can run counts on those tables, just like you will do with traditional SQL. Okay, so that's all I have today. I truly apologize for the technical issues. I think killing the video actually helped. If you want to learn more, if you have questions, please find me at the Expo booths. I'll be there to answer any questions you may have. Thank you very much for your time today.
Thank you, Tonio. That was great. I put a quick survey in the chat for everyone to fill out, just to give us a little bit of feedback on our sessions. If you don't mind taking a little bit of time to fill that out for us. And then we are officially going into our lunch hour. So we encourage everyone, get up, move around a little bit. Sitting in front of your computer all day, I know we all do it, but it's important to move. And if you have some time, please visit some of our expo booths, go do some networking. I think, we've got an hour and a half for lunch. Take advantage of it a little bit if you want to. But thank you so much for coming to the breakout sessions, and we'll see you guys here after lunch soon. Hey everyone, Tonio was having some technical difficulties, lost his internet connection. So if you want to hang out here for a couple of minutes while we work to get everything back up and going for him, that would be great. Promise you didn't lose everything. It's just the nature of doing this virtually. Sometimes when we all have different internet, the internet doesn't work. So we will get him. Oh, looks like there he is.
Okay. Can you guys, and it's my browser died, I really apologize for that. I drove all the way to work to make sure I have the best internet possible, and still managed to kill my browser here. Let me continue with the deck. Give me 1 sec, I'm gonna share my screen. Okay, so I probably lost you when I was talking about, let's go back to scaling, right? And how to scale these NoSQL, these Cosmos DB databases. And it's super easy, right? It doesn't die on me now. Hello, can you guys hear me now? Yes, excellent. Okay, perfect. Emily, can you say something to see if I can hear you?
I was having some audio issues as well. Can you hear me? Nope. Oh no. The joys of a virtual conference. We're gonna get this figured out, guys.
Okay. Can you guys hear me again?
Yeah. Yes. Can
Fine.
you hear me?
Both loud and clear. Excellent. So sadly, I cannot hear Emily. Looks like somehow my audio is broken, but if you guys can hear me, that's great. I think Emily's typing something for me. So perfect. So am I ready to go then? Yes, excellent. So good morning, everyone. My name is Tonio Lora. I'm a principal cloud solutions architect for Microsoft. Hopefully you can all see my screen, what I'm sharing right now, my deck. Today, I'm here to talk about how to build large-scale NoSQL-based applications using Cosmos DB. Okay. By the end of the session, my hope is that you will all know what Cosmos DB is, the type of problems that it solves, some reference architectures, and some ideas on how to get started. Okay, I'll be looking at the chat here on my left side. So if you have questions, feel free to type them as I cannot hear you, and I'll try to answer them as I go through the slides, okay? Perfect. So modern apps face new challenges, right? Long time ago, it was relatively easy to build these applications, right? But now these applications are distributed around the world, right? We have customers in different continents, and they have different expectations, right? Managing and syncing data that's stored in different places is challenging, okay? At the same time, these apps needs to be highly responsive, right? We're thinking about a customer that's in front of the web browser. It can wait 1 or 2 minutes for a transaction to happen, right? We're usually talking about milliseconds. So there is a need for these apps to be highly responsive. At the same time, they need to process large amounts of data and sometimes complex data, right? Think about the IoT, Internet of Things scenario where hundreds, if not thousands of sensors are sending telemetry data, and that telemetry data needs to be captured, processed, and made available for analytics, okay? Apps also need to scale, right? Both in storage and throughput. So maybe you deploy your application for one customer here in the US, and then you have 1,000 more customers in Europe, right? And you need to be able to scale your app easily without having to re-architect the entire solution, okay? Offering low latency to global users, right? As in the previous example, if we have a customer or a set of customers in Australia, another in India, another in West US, right? We want them to have the same experience in terms of latency, regardless of where they are located, okay? So there are new challenges that these modern apps face. Now, as a result of these new challenges, NoSQL databases have emerged, right? They have increasingly supplanted relational databases in many modern applications, right? This NoSQL database design emphasize non-relational data storage, right? So in other words, instead of storing data in the rigid structures, right? The columns, tables, relationships, um, NoSQL uses any number of methods, right? In some cases, a combination of methods actually to store the data in a way that's decentralized compared to relational databases, okay? Now, NoSQL is not for all these scenarios, but if your application faces one of the challenges described before, then NoSQL is the right solution for you. Now, with those challenges in mind, highly influenced by the work of Dr. Leslie Lamport, Turing Award winner and world-renowned computer scientist, Microsoft created Azure Cosmos DB. right, is a platform as a service solution, right, that is fully cloud native. So it's built for the cloud from the ground up, okay? And it's also an Azure, what we call an Azure Ring Zero service, which means that it's available on every Azure region, right? Every time we create or we set up a new Azure region somewhere in the world, Cosmos DB has to be there, okay? Now, Cosmos DB, it's a NoSQL database, so imagine now. And it's unlike the relational databases of the world where you, again, are dealing with tables that contain rows and columns, right? And relationships, of course. Cosmos DB offers several data models, including, as you can see on the screen, key value, column family, document, and graph, right? With a bunch of APIs, so you can build your application using any of those options. For example, if you have graph-related data, you can use the Gremlin API to query and process that information, right? Or if you have document-oriented data, you can use the Mongo API, okay? Now, we do have a bunch of capabilities that make Cosmos DB a great database to build your applications on. And what I'm going to do now is just briefly run through them, right? And as I do, I'll be jumping to the Azure portal so you can see how how easy it is to enable these powerful capabilities. Okay, the first one is security, right? This is something that's it's super critical, very important when you build your modern applications, right? As you may imagine, an application that's distributed around the world has to be complying with multiple policies from or governance policies from different parts of the world, right? From anything from GDPR to ISO to HIPAA to SOC 1, FedRAMP, HITRUST, and many of them, right? And of course, Cosmos DB have you covered there, right? You don't have to worry about those things because Cosmos DB is compliant with those certifications. And of course, I'm going to just go back quickly to the previous slide. Of course, data is always encrypted, right? It's encrypted at rest. And this, when I said data, I mean all the data, the index, backups, attachments, they're all encrypted, okay? And this is automatically enabled by default. So you don't have to do anything on your application. Now, guarantee low latency. Cosmos DB provides an SLA back guarantee, right? For a point read that is less than 10 milliseconds. And SLA back means that if we fail to provide you with that throughput, right, with that latency, we'll pay you for that, right? So financially support SLAs is a big thing in Cosmos DB. But latency is not the only SLA that we guarantee, right? Azure's Cosmos DB is the only cloud service that provides money-back SLAs across latency, high availability, throughput, and consistency, right? And as you can see, you can easily build 5.9 application, 5.9 available application using the service. Now let's go into a little bit more detail of the NoSQL world, right? On the traditional relational databases, we have, it's easy, right? These applications are usually sitting on a single server, right? Maybe you have a failover server somewhere else, so it's a replica, read-only replica. In NoSQL databases, you usually have a distributed model, right? Distributed means that you only have the data a partition and distribute geographically in different places, and it's also replicated. And to make sure that the data is consistent, right, that we have these many copies and you have customers maybe updating the same records in real time, that's a hard challenge, right? And sometimes a challenge that you don't need, right? You think about a website, right? If I am updating my session information, right? Maybe what products I have on my cart, others shouldn't care about that information, right? Other persons shouldn't have any visibility on my own session. Because of that, Cosmos DB offers these 5 well-defined consistency models, right? And these consistency models that don't force you into making a choice between the extreme of a strong consistency, which is what traditional relational databases offer, or eventual consistency, which is what most NoSQL databases offer. Right? Instead, they allow you to make choices appropriate for your application. Now, strong consistency here guarantees it's very similar to a traditional relational database, right? Once an operation is complete, it'll be visible to all readers and across all the environment, across all the replicas, right? A session consistency is similar to a strong consistency, but applies only to your session, right? It guarantees that if you write an event or a piece of data, right, a piece of business transaction, the next read will read what you just wrote, right? What we call monotonic reads. And then you have different options for boundless, stainless, and consistent prefix, which are a little bit more, I guess, difficult to explain here. And maybe if you're very interested, you can jump later to the booth, and we can talk about those. And by the way, these are just the default modes that you set up at the database level. On your application, you can always relax the consistency model for your specific transaction, okay, or session. Now I'll jump to the Azure portal to show you how that works. Okay, yep. Hopefully you can all see my Azure portal. If you're not familiar, just like any other cloud, we have a portal there where we can manage all of the services that we deploy. Okay, so this is just a quick dashboard with some of the services. You can see there's not a lot of activity right now. And this is my Cosmos DB resource, right? What I can see here is the resource group with the Cosmos DB is created. I have a couple of containers that are part of the same database. And I have some information about some monitoring information, right, at glance. So high level, the number of requests, as you can see at this time, for example, 4 a.m., I have 47,000 requests. And these are requests per second, right? So what I have is an application and a VM that's sending transactions, right, and read transactions to these applications. So you can see some monitoring data here, okay? Let's see, and now I was talking about consistency models. So let me show you the default consistency for this database. And as the portal loads, as you can see, the default consistency here is session consistency, right? And very interesting here, Cosmos DB shows you what that means in a distributed environment, right? Where you have East US writes, East US reads, Australia Central reads, and Australia East reads. And you can see how these two distributed regions, they follow, okay, what the write and reads on the same session do in a consistent way. So they apply to the session. And you can also see what happens if I shift to eventual. Right, I won't save, but you can see what happens. This is US writes, and all the other, regardless of where you are, they follow, but they follow in not the right order, right? So eventual consistency means that eventually the distributed region will read the most accurate version of the data, but there's no guarantee on when will that happen. Right? You will usually have in less than 1 minute, but there is no guarantees. And remember, we pay you back, we pay money back if we don't fulfill our guarantee. So we don't have any for eventual consistency. So let me jump back to the deck. Okay, so Azure Cosmos DB also can scale, right? I mentioned this was one of the challenges of modern applications, right? And we can scale both the storage and the throughput. And the throughput here is how fast the operations are performed, right? And scaling Cosmos DB database is extremely simple, right? It's super easy. And I'll show you how that's done. And in my case, I'm gonna show it to you manually, okay? So for that, I'm gonna go to the Data Explorer. Okay, so it looks like my browser is not responding. It's a great day for presentations, apparently. Okay. Can you guys still hear me?
Hi, Tonio. My name is Emily. I'm the AIM moderator. So if you need anything during the session, just let me know. I'm here on the back end.
Hi, Emily. I cannot hear you.
Oh, that's not good.
We hear both of you, so the problem is on my side. Let me fix my audio. Give me 1 second, please.